Good morning, everyone. Welcome to Learning Management System. It is an initiation of Department of Collegiate and Technical Education. Dear students, today I am going to discuss about automobile electronics, that is Unit 2 of Applications of Electronics Engineering. Applications of Electronics Engineering is fifth semester subject of Diploma Electronics and Communication Engineering. Before going into this session, I would like to make a simple recap or revision of previous session. In last session, we have discussed about anti-lock braking system. The anti-lock braking system is one of the safety system. Before going into anti-lock braking system, we must understand about conventional braking system. The braking system is a part of safety system. When a driver wants to stop a vehicle, then he uses the brake or braking system. If a driver driving a car on wet or icy road with the conventional braking system in his vehicle, if he applies the brake, then that brake makes the wheel to lock, and that may result the skidding of the vehicle. That sudden lock of the wheel may skid from one position to another position, or it may go beyond the braking point. Sometimes it may go in the undefined direction. Consequently, it may encounter the accident or road accident. Dear students, then what is the purpose of ABS here? The ABS, then what is use of ABS, that is anti-lock braking system? Dear students, the name itself indicates anti-lock braking system. That means it will not going to lock the wheels upon application of the brake. The anti-lock braking system is one of the popular braking system that has been used in the automobiles. When ABS is implemented in the vehicle, assume that if a driver driving a car or vehicle on the road, if the road is icy or wet road, the vehicle with ABS, if the driver applies the brake, then the ABS system will not lock the wheel instantaneously. Instead of that, it applies the brake in on-off fashion and ensures that it will not skid the vehicle from the braking point. It will also help the vehicle to stay in course, and it also help the vehicle to go in the defined direction. Dear students, ABS is one of the popular electronic system. The components involved in this ABS are wheel sensors, electronic control unit, hydraulic pumps or hydraulic valves, and the braking system. The wheel sensor, it is a sensor which gathers the information from wheel. It observes the wheel rotation and it gathers the information and it sends that information to electronic control unit. The electronic control unit, it is the brain of ABS. It comprises of microcomputer. Microcomputer has both software and hardware parts. When a wheel sensor gathers the information and it's sent to ECU, that is electronic control unit. Electronic control unit process that information and sends to the modulating valves. Accordingly, the modulating valves process that information and send that regulating signal to the braking system. This is all about the component of ABS. Now we will understand how ABS works. Assume that the ABS system is implemented in the vehicle. When a driver presses the brake pedal, then that stoppage of wheel, or when once the wheel is stopped, that information within a fraction of second it goes to wheel sensor, and that captured information is given to the ECU. ECU process that information and sends to the hydraulic valves, where hydraulic valves ensure that the braking system should not get locked. Instead of that, it sends the on off signal to ensure the braking is optimal. Dear students, in this way the anti-lock braking system works. Now coming to today's topic, that is electronically controlled suspension system. Dear students, we know that the introduction of electronics in automobile has brought the revolutionary changes. Due to the introduction of electronic technology in automobile has increased the performance, mileage, safety and reliability of the vehicle. We will try to understand this with the help of this diagram. Before going into electronically controlled suspension system, we will understand what is suspension system. Dear students, suspension system, dear students, the suspension system is a system which is used to isolate the car body from the vertical movement of the wheels. It is used to isolate the car body from the vertical movement of the wheels. How it can be achieved? Mechanically, or in mechanical system, it looks like this. This is called shock absorber. The shock absorber has the following components. It has shock absorbing strut and the coil spring. In the figure, we can see that the strut is connected to vehicle body. On the other side, the other end is connected to wheel assembly. And this part we usually find at the wheel side. Let me draw a simple diagram. Assume that this is a car and this is a wheel. Between the car body and the wheel, here we find the shock absorber. In one more figure, the graphical representation of shock absorber is given. Here we can see that one end is connected to vehicle body and another end is connected to wheel assembly. And this is the spring. The spring plays a very important role in absorbing the shock. Dear students, now we will understand some very important terminologies or parameters that are related to suspension system. The first parameter is ride. Ride is defined as it is a motion of the car body in response to the road irregularity. That means in this figure we can see that this is a car which is moving on the road. Later it encounters some road irregularities. Then due to that this car body goes up and down. That is called ride. Similarly, what is handling? Handling is upon application of hard brake or sudden brake, the movement of this vehicle is known as handling. Dear students, in this figure, we can see that this is shock absorber which is connected between the car body and the wheel. Dear students, in this figure we can see that this is the shock absorber which is connected between the car body and the wheel. This acts as suspension system. As we have seen, the one end is connected to the car body, another end is connected to the wheel. Since it has suspension property, it provides the damping. Now, how we can overcome the ride and the handling? In previous slide, we have seen that ride is the motion of vehicle body when it encounters any irregularity on the road. Similarly, handling is a parameter where the vehicle body moves up and down due to the hard braking. Now, how we can control or how electronically controlled system may overcome this problem? Dear students, in order to overcome the ride problem, we must reduce the damping of shock absorber. What is damping? The movement of up and down of this shock absorber is known as damping. In order to reduce the ride, we have to lower the damping. This is one way. On the other way, we have the handling. Handling happens if and only if the braking or hard braking is applied. This handling problem can be overcome with the help of electronic control system, and that can be achieved with the help of improving the or increasing the damping. In simple word, I can say that riding can be improved by lowering the shock absorber damping. Similarly, handling can be improved by increasing the damping of shock absorber. Dear students, this can be achieved by electronically controlled suspension system. As I said you earlier, dear students, the introduction of electronic technology in automobile system has made phenomenal changes. It has made automobile vehicle very reliable, efficient. It has increased its mileage as well as its performance. Now we will see how electronical system is going to help in the control suspension system. This is the block diagram of electronically controlled suspension system. In electronically controlled suspension system, we have the following parts, that is sensor, electronic control unit, air compressor, actuator, and we also has electric brake system. The sensor, which gathers the information such as body acceleration, wheel body distance, steering input, and wheel speed. Let me elaborate regarding, or let me give the detailed information about these input parameters. Dear students, what is body acceleration? Since the body moving in the in a particular direction, the movement of that body is captured. That is called body acceleration. Similarly, wheel body distance. What do you mean by wheel body distance? Assume that this is a vehicle and it has a wheel under it. and it is connected with the help of shock absorber. When a car is moving on a road in a particular direction, then the movement of this wheel changes, or I can say the distance between the wheel and body gets changes every time. That information is captured with the help of sensor, and the same information is sent to electronic control unit. Similarly, steering input. The steering is very important part of any automobile vehicle. Let me elaborate you how steering works. Dear students, the steering is in round shape, and nowadays we also has power steering. The steering is connected with one axle, and that is in turn connected to front wheels. That is connected to front wheels. With the help of gear systems, with the rotation, if I rotate this steering, that may rotate or change the direction of the front wheel. This changing information is captured with the help of steering input. Similarly, the wheel speed information can also be captured with the help of wheel speed sensor. When the vehicle go into a speed, whenever a driver presses acceleration pedal, because of that it gets momentum and it moves fast. This is all about the basic parameter of electronically controlled suspension system. Now coming to the sensor. The sensor is a device, sometimes it is also known as transducer, which converts the signal from one form to another form. The signal or input signal, it may be any form. It must be converted to electrical form. That is known as sensor. For example, if I use ultrasound sensor here for or to check wheel body distance, that distance is calculated with the help of ultrasound sensor, and that converts and sends the electrical signal with the help of that sensor. Dear students, once we convert that physical parameter into electrical parameter, now it's time to convert analog to digital. For that I use ADC. If the sensor output is in analog, if it is in digital form, then the same digital data can directly feed to, or we can directly feed it to electronic control unit. If that data is in analog form, then we have to convert it from analog to digital. For that purpose, we have to use the ADC, that is analog to digital converter. Similarly, we also has electronic control unit. In electronic control unit, it comprises of different chips. Usually, the electronic control unit receives the information from the input sensors. The information such as steering angle, gravity, road speed, height of the vehicle, front side as well as the rear side. The electronic control unit comprises of the chip like microprocessor and or microcontroller. Dear students, we know that microprocessor as well as microcontroller has ability to process the information. It has input ports as well as output ports. Internally, it has ALU, arithmetic logic control unit, timers, counters, and memory devices such as RAM and ROM. The manufacturers also has facility to program those chips. Once the manufacturer program those chips accordingly and fit into this electronically controlled suspension system, then it will become ECU. that is electronic control unit. What is the role of ECU here? It takes the information from the input sensors and process that information and send it to output devices through the output pins. It may be used to control the air compressor or the actuators or the electric brake system. Before going to the next slide, we must know what is actuator. Actuator performs the motion. For example, sensor senses the information and send it to the electronic control unit, whereas the actuator is a device which creates the motion upon receiving the signal, and those actuators can be used as strut or can be connected to strut damper aperture. Similarly, in electronically controlled system, we also use the air compressor. Air compressor means with the help of pressure of air or by extracting the air pressure, it creates the suspension, and these system can be controlled electronically. Hence, these are the very important part of electronically controlled suspension system. Dear students, now we will see the different condition where and how electronically controlled suspension system works. The first condition is degree of drive override. Assume that you are driving a car on a road and there is a vehicle in front of you. If you want to overtake that vehicle, then obviously you apply more speed. Under that condition, the damping increases. Under that condition, the sensor gets the information from the vehicle speed and process that information, or I can say sensor take that information, convert it in digital form and give it to the electronic control unit. The electronic control unit here gives the appropriate signal to either air compressor or the actuator. The role of these output device here to maintain the proper damping. If we are in the right position, then it has to lower the damping. If we are in handling position, then it must increase the damping and make the road journey very smooth and keep the vehicle in the level. Now coming to the next topic, that is cornering. What do you mean by cornering? Assume that we are driving a car on a road. If we encounter any turn, while taking the turn, we use the steering. Here we have steering input. We use the steering to turn, and we also change the vehicle speed. Here we can see that steering angle or vehicle speed. These two informations are captured with the help of sensor. As I said you earlier, sensors are the device which converts one form of energy to another form of energy. It captures the information from steering input, it captures the angle as well as the vehicle speed from the acceleration pedal. Both the informations are sent to the processor, that is called electronic control unit, where electronic control unit process that information and send the appropriate signal to air compressor and the actuator. These two devices ensures that the vehicle must be kept in the level and it maintains the damping of the suspension. In this way, these two parameters are used, and the sensors and ECU plays very important role in the cornering. Similarly, we also has the braking. What do you mean by braking? In previous slide, we have seen that when the driver wants to stop a car, then he applies sudden brake. Under that condition, we gather the information from brake pedal. We gather, or the vehicle gather the information from brake pedal, and at that time vehicle speed get reduced. These informations are captured by the sensor. Again, sensor convert that physical information to electrical information or electrical signal. If it is in analog form, that is converted into the digital. If it is in digital form, that is directly taken into consideration and it is sent to electronic control unit. Electronic control unit comprises of the microprocessor or microcontroller, which is programmed to control the riding and the damping. In the braking condition, the electronic control unit receives the information from sensor and process it and send it to the output device, that is air compressor and actuator, so that it adjusts the damping as well as the height of the car during ride position as well as the handling position. Here we mainly focus in the handling because handling happens in the braking condition. What is handling? The movement of vehicle body under the braking condition. Under such condition, the damping of vehicle must be increased to improve the suspension. Now coming to the next topic, that is bouncing and pitching. Bouncing and pitching, we encounter these while driving a car on irregular roads. Under these conditions, it monitors the front and the rear suspension height and the relationship and the suspension travel. What does it mean? That means the sensor is going to observe the wheel body distance. It's going to observe the wheel body distance. It may use the sensor, maybe ultrasound sensor. With the help of ultrasonic sensor, it calculates or measures the distance between the wheel and body, and that same information is given to electronic control unit. The electronic control unit comprises of microprocessor or microcontroller, which is programmed to maintain the proper damping of the valve as well as suspension system. That electronic control system gives the information to this output device to maintain the proper damping. Dear students, electronically controlled system helps in all the conditions, be it a cornering, be it in hard braking, be it in bouncing and pitching. Once the ECU collects all the information and it process it and it control all the output devices, be it a air compressor or actuator. If the vehicle is in ride position, then this will reduce the damping. If the vehicle is in handling position, then it will increase the damping so that the vehicle level must be maintained on the road. Dear students, before concluding this session, I would like to give the brief introduction about the air suspension system. This air suspension system, we have seen this in the previous block diagram. Now let's see its important parts. Assume that this is a car body and this is a wheel. Here the suspension system is connected. By this means we measure the height. This is the height sensor. This height sensor measures the distance between the car body and the wheel. Upon changing this distance, this information is sent to the control module. That is, control module comprises of microprocessor or microcontroller. This sends a signal which is shown in the red color and gives the appropriate information to air pump and the dryer. The combination of air pump and dryer, if necessary, it will send the air to expand this airbag with the help of this solenoid valve. If we want to reduce the distance between the wheel and the body, then the air dryer, I can say pneumatic type pump, is used to suck the air to reduce the distance. This is the air line. Dear students, in this way, the electronically controlled suspension system is used to maintain the damping of vehicle both in the ride position as well as in the handling position. Dear students, now we will start with some MCQ to test your knowledge. Please answer this question. The first question is, dash system is used to absorb the shock. You have four options: suspension, ignition, power, and all of the above. Please try to think and try to answer to this question. What system is used to absorb the shock? Yes, students, the answer to this question is suspension system. Suspension system is used to absorb the shock. Now we will move to the next question. The question number 2. Suspension system use dash to absorb the shock. Whether it use rod or bearing or shock absorber or all of the above. Please try to think over it. This concept we have discussed in the previous slides. Suspension system use dash to absorb the shock. Yes, dear students, the answer to this question is shock absorber. Shock absorber is used in suspension system to absorb the shock. Now, after the second question, we will move to the third question of the MCQ. The third question is as follows. Dash is used to connect vehicle body and coil spring. I will repeat. I repeat. Dash is used to connect vehicle body and coil spring. Options are shock absorbing strut, bearing, wheel, or none of the above. Dash is used to connect vehicle body and coil spring. The answer to this question is shock absorbing strut. The shock absorbing strut is used to connect the vehicle body and coil spring. Now we will move to the next question, that is question number 4. The motion of car body is in response to irregularity is known as dash. Options are handling, ride, move, or all of the above. I repeat, motion of car body in response to road irregularity is known as dash. What it is called? The motion of body due to irregularity of the road. Please think over it, dear students. Yes, the right answer to this question is ride. Ride, the motion of car body in response to road irregularity is known as ride. Now we will move to the next question, the question number 5. Let's move to the next question. Dash refers to how well the car body responds to dynamic vehicle motion such as hard braking. Options are handling, ride, move, or all of the above. Think over it. We have discussed this concept many times during our presentation. Yes, dear students, the answer or the right answer to this question is handling. Handling refers to how well the car body responds to dynamic vehicle motion such as hard braking, that is called handling. By improving the damping, the handling can be reduced. Similarly, by reducing the damping, the ride can be improved. Now we'll move to the next question. The suspension system is connected between car body and dash. You have four options, that is wheel, bonnet, both A and B, or all of the above. Dear students, you have four options. Please think over it. Try to apply your knowledge which you gathered or which you learned during this session. Yes, students, you found it right. The answer to this question is wheel. The suspension system is connected between car body and the wheel. That is option A. Now we will see the question number 7. Let's see that question number 7. Electronically controlled system uses dash to reduce the damping. Options are electronic control unit, electrical control unit, both A and B, none of the above. What does it use to reduce the damping? Or what is the brain of this electronically controlled suspension system? You have four options: electronic control unit, electrical control unit, both A and B, D, none of the above. Dear students, please think over it. It's quite simple one. The answer to this question is option A. Electronic control unit. Electronically controlled system uses ECU to reduce the damping. Now we will see the next question. The question number 8. Electronically controlled suspension uses dash parameters. The electronically controlled system uses dash parameters to maintain the proper damping of suspension system. Options are body acceleration, steering input, vehicle speed, all of the above. Dear students, please think over it. What may be the right answer? The right answer to this question is option D, that is all of the above. Electronically controlled system gathers the information such as body acceleration, steering input and wheel speed to maintain proper ride and handling or proper suspension system with proper damping. Now coming to the question number 9. In electronically controlled suspension system uses dash input to damping of vehicle body. You have four options: sensor, brake, wheel and all of the above. Please think over it. Yes, students, the correct answer to this question is the sensor. Sensor uses as input for damping of the vehicle. And the last one is dash is used to control the strut damper aperture. We have four options, that is actuator, regulator, sensor and none of the above. Dash is used to control the strut damper aperture. Four options are actuator, regulator, sensor and none of the above. The correct answer to this question is the actuator. This is all about MCQ. Dear students, this is about the reference which I referred to create this PPT. Dear students, thank you very much. Dear students, if you have any suggestion, please do write your suggestion to this following email ID, that is lms.dtek@gmail.com. Thank you.